In this video, we are going to revise some questions from Science Paper 2 of 2019 for internal. Now, under this video, we are going to cover the three sections A, B, and C. So let's first begin with section A. So the first question here, which of the following is an example of the application of chemistry in a home? So from the multiple choices, the first one, the use of amplifier in a radio, no. The use of cosmetics, yes. Production of ammonia, that is industrial. D, industrial production of alcohol. So the best answer here is B. So B, here we can see the use of cosmetics. Cosmetics are substances that such as like lotion. Now we can move on to question 2. The best apparatus that is used to accurately measure a required fixed volume of a reagent during titration is. So the accuracy here, we can have this one. So this is what we can use, or we're just looking at the pipette. Now question 3. The best method to separate a mixture of sand and diesel. So sand is insoluble, meaning it cannot dissolve in water. Then we know that diesel is a liquid, so we are looking at the method that we can use if we want to separate an insoluble substance from a liquid. So the best method here is filtration, D. Then we can move on to question 4. Identify an inert gas from the diagram below. Inert gas are elements that are found in group 8, and these elements are naturally stable. So one of the characteristics of these elements, they are monatomic. This means that they consist of only one kind of atoms. They cannot bond with any. So if you look at A, here we can see the circle is bonding with another circle. So this is, we have a bonding. A, no. Then B, we can see that we have this circle which is unshaded, and the shaded one. Here we can see that we have different kinds of atoms. So B, no. Now for C, we can see that we have atoms that are unshaded. So here this is implying that we have the same kind of atom. So our answer is C, because D, here we can see that we have a bonding. Now let's move on to, okay, so now we can go to question 5. The following equation is incomplete. 2 lithium hydroxide plus sulfuric acid is equal to X. So the first question here is, what is X? Now let's look at the equation. The equation is between a metal hydroxide, which is a base, and a sulfuric, an acid. So here we are expecting to have salt and water. So let's see. So here we have 2 Li or H plus sulfuric acid. So the product is the lithium will react with sulfate, giving us Li, sulfate. Now the lithium is in group 1, so it has a valence of 1. Sulfuric has a valence of 2. So here we are going to have 2 atoms of lithium plus water, 1 molecule of water. Now let's look at we balance it. So for us to balance, let's calculate the number of atoms of hydrogen, because we can see that lithium is already balanced. So from these 2, we can see that we have 2 atoms of hydrogen from the lithium hydroxide and 2 atoms of hydrogen from sulfuric acid, making these to be 4. So we need to put 2 in front of water so that we have 4 atoms of hydrogen. Now let's check for oxygen. For oxygen, we can also see that there are 2 atoms of oxygen from the lithium hydroxide and 4 atoms of oxygen from the sulfuric acid, making this 6. So here also we can see that 6. So from the multiple choices, we want to choose a multiple choice with this. So from there we can see that our answer is A. Now let's move on to question 6. Which of the following molecules has a triple bond? Triple bond. So the best way to know the number of bonds an element or a compound has, you just have to look at the number of the valence number. So for chlorine is coming from group 7. 7 has a valence of 1, so chlorine forms one bond. It has one bond. Now let's move on to B. B has carbon dioxide, so the central atom is carbon. Carbon has a valence of 4, so carbon has 4 bonds. Okay, now let's move on to nitrogen. Nitrogen is coming from group 5. Group 5 has a valence of 3. So here, if we have this nitrogen, another this nitrogen, we are expecting to have 3 bonds since nitrogen has a valence of 3. So the answer here is a C, since we have a triple bond. Now let's move on to question 7. The equation below shows the preparation of a salt. Okay, now from the equation we can see that we have silver nitrate, which is a soluble salt, plus sodium chloride, which is a soluble salt. So we are looking at preparation of an insoluble salt by using 2 soluble salts. So the insoluble salt is silver chloride. You just have to commit that to memory. Then for sodium nitrate here, that is a soluble salt. Now for the question, which of the following gives the correct description of the equation? Multiple choice number A, salt. Silver chloride is a salt, yes. Then type of salt, insoluble, yes. Method of preparation, separation, filtration. So we can see that the answer is A. So here, where the filtration comes in is silver chloride is an insoluble, then sodium nitrate is soluble. So the method of separation, if you want to separate an insoluble salt from a soluble salt, we use filtration method. That's the reason why the multiple choice number A is correct. So we can now move on to question 8. What mass of copper 2 oxide would react completely with 500 cubic centimeters of a 0.5 molarity dilute sulfuric acid? So here we can see that we have been given the volume and concentration for acid. Now the question is, we want to find the mass of copper 2 oxide. Okay, so let's so the first thing that we need to do here, we need to have a balanced chemical equation. So the chemical symbol for copper oxide, CuO, solid, plus sulfuric acid, it is HSO4 aqueous. Then the copper will react with sulfate, giving us copper sulfate. Now remember, copper, we have been given copper 2, so it has a valence of 2. Sulfate has also a valence of 2, so these two will cancel, giving us the chemical formula that we have written for copper sulfate. Then plus water. Now let's check if our equation is balanced. We have one atom of copper here and also 1 atom of copper. Then 5 atoms of oxygen, 1 from copper oxide and 4 from sulfuric acid, giving us 5. Here we can also see that we have 4 atoms from copper sulfate plus 1 from water. Then 2 atoms of hydrogen and also 2 atoms of hydrogen from water. So our equation is balanced. Now our first step here is, we have been given the volume and concentration for acid. So we are going to use the volume and concentration of this acid to find the number of moles. So the formula now is number of moles is equal to concentration multiplied by volume. So the concentration is 0.5. Now the volume is 500 cubic centimeters. The rule is volume should be in decimeter cubed. So this 500 should be divided by a 1000 to convert it into decimeter. So if we divide 1000 into 500, we are getting 0.5. So here we get 0.5. So 0.5 times 0.5 is 0.5 times 0.5. So I'm getting about 0.25. So 0.25 moles. So these are moles of sulfuric acid. So these are moles of sulfuric. So here we have 0.25. Now for us to find the mass, the formula for mass in our case, so mass is equal to number of moles multiplied by molar mass. So what we are doing is we want to use the number of moles of sulfuric acid to find the number of moles of copper oxide. So let's look at the mole ratio. So the mole ratio, we can see that we have 1 here and also 1 here. So these two have the same mole ratio. Since they have the same mole ratio, they will also have the same number of moles. So even copper oxide has 0.25. So we have 0.25. Okay, let me create some space here. So we have 0.25. Now let's find the molar mass for copper oxide. Now copper, okay, let me use copper oxide. So copper, we have 1 atom of copper. Copper has the mass number of 64 times 1 plus C. Oxygen is 16 times 1. So 64 times 1 is just 64 plus 16. So 64 plus 16 is 80. So we put 80 here. So 0.25 times 80, I'm getting 20. So my final answer is 20 grams. So from the multiple choices, our answer is D. So this is what you can do for you to find the mass of one substance using the number of moles of another substance. Now let's move on to question 9. The table below shows some transition elements and their uses. So which one is the correct use in the contact and Haber process? So contact is the process by which sulfuric acid is produced. Then Haber process is just the process by which ammonia is produced. So under Haber process, for Haber process we use iron, while for contact process we use vanadium. So the answer is B. Okay, now let's move on to question 10. Which of the following arrangement below is suitable for collecting a soluble gas and is denser than air? So since this one is denser than air, we are going to have a downward displacement of air. Now, then also we are told it is soluble. So since it is soluble, meaning it dissolves in water. So you cannot use water. So the best method here is C. Okay, now let's move on to question 11. The relative formula mass of calcium hydrogen carbonate is. So let's look at calcium hydrogen carbonate, the formula. Okay, so let's look at just use here. So from the chemical formula, we can see that we have one atom of calcium. So calcium times 1 plus C. Now here we can see that we have a subscript of 2. This 2 will multiply with everything inside the bracket. So we are going to say 2 times hydrogen plus. Then for carbon, it's C times 2. Then for oxygen is oxygen multiplied by, so we are going to Taimusha 2 times 3, giving us 6. The mass number for calcium is 40 times 1 plus C. For hydrogen is 1 times 2. Carbon is 12 times 2. Oxygen is 16 times 6. So 40 times 1 is 40 plus 1 times 2 is 2. 12 times 2 is 24 plus C 16. So 16 times 6, 16 times 6, I'm getting 96. Now let's add. So 96 plus 24 plus 2 plus 40. So I'm getting 162. So 162 is my final answer. So from the multiple choice, our answer is D. So for a compound with a formula like this one, where we have CaHCO3 and the subscript here, this number 2 should multiply the numbers inside. So 2 here, also 2 here, also 2 here. That's why we got 6 atoms of oxygen. Now let's move on to question 12. Which of the following statements explains why magnesium, calcium, and barium are placed in group 2 of the periodic table? So if you want to determine the group in which an element is placed, you just have to count the number of electrons in the outermost shell. So the number of electrons in the outermost shell determines the group in which an element is found. So from the multiple choices, A, they all have 2 electrons in the outermost shell. This is our answer. So magnesium, calcium, and barium have 2 electrons in the outermost shell. Okay, now let's move on to question 13. How many molecules are found in 6.0 cubed decimeter of carbon dioxide at RTP? So molecules, so the formula is, we are solving for molecules, which is X, so you can just say X is equal to number of moles multiplied by Avogadro's constant. So here there is a need of finding the number of moles. So since we have this volume, we can find the number of moles, and we have been given the condition for RTP. So let's find the number of moles. So the formula is number of moles is equal to volume of the gas divided by the molar volume. So the volume of the gas is 6.0, so just say 6 divided by, then our molar volume, RTP. So whenever you have been given the condition of RTP, use 24. So we can now do the math. 6 divided by 24. 6 divided by 24, I'm getting 0.25. 0.25. So this is the number of moles of carbon dioxide. Now we can move on to find the number of molecules. So X is equal to, the number of moles is 0.25. Then Avogadro's constant is 6.02 times 10 to the power 23. So now let's find our final answer. So 0.25 times 6.02 raised to the power 23. So I'm getting about 1.505 times 10 to the power 23. So 1.505 times 10 to the power 23 molecules. So let's see if we have this one. So from the multiple choices, the answer 1.5 is A. So this is our correct answer. So remember to commit the formulas to memory. So one of the formula, if you are for the number of moles, or for the number of molecules, ions, or number of atoms, the formula is number of moles is equal to X over Avogadro's constant. So the X can represent the number of atoms, the number of molecules, or the number of particles. So by making X the substitute formula, therefore we can see that now for us to find X, we need to multiply the number of moles multiplied by the Avogadro's constant. Now let's move on to question 14. Which of the following is an alloy? So an alloy is a substance that consists of two or more elements. Now, rust is not an alloy. Silver is just an element. Bronze is, so the answer here is C. Bronze is an alloy. Number 15. Halogens are useful elements but also causes harm to the environment. Which of the following is true danger of the halogens? The first one, cause HIV and AIDS in the human beings. No. Deplete the ozone layer. Yes. Are used to treat wounds. No. Or release harmful radiation. So the answer is B. Such as the compounds such as chlorofluorine can cause or deplete ozone layer. Okay, now let's move on to question 16. Now question 16. The best way of preventing spanners, pliers, and screwdrivers from rusting is A. Sacrificial, B. Tiring, C. Oiling, D. Galvanizing. So the best way is D. Galvanizing. We can't use oiling. Sacrificial protection. So the best one is galvanizing. Number 17. The gas that combines with hemoglobin and reduce its capacity to carry oxygen in the body is, so this one you just have to commit to memory, is carbon monoxide. So that is the gas that can cause suffocation. 18. Which of the following substances is not a synthetic fiber? So we are looking at a substance that is just its occurrence is just naturally. So synthetic substances or fibers are those that are man-made, those that were made by human beings. So from there we can see that nylon is man-made, cotton is natural, so the answer is cotton. Because polyethylene is man-made, polyester is also a man-made. Now the compound represented below is, so let's look at this compound. We have two carbons here, two carbons. Then we can see that we have 4 electrons. So this bond here represents 2 electrons. Also this bonds here represents 2 electrons. So here, whenever you see 4 electrons between 2 atoms, just know that you are going to get 2 bonds. If you have 6, 3 bonds. 6, 3 bonds, 4, 2 bonds, 2, 1 bond. Then let's look at the number of hydrogen. This one has 1, 2, then also 1, 2. From there, we can see that we are looking at a compound with double bond and a compound with 2 bonds. 2 carbons. So from the prefixes, a compound with 2 carbons is F. Then since we have a double bond here, we are going to have ENE. So the substance, this one is an ethene. So the answer is A. Then for 20, the last question for section A, what is the name of the compound below? So let's look at this compound. Maybe let's use a displayed structure. So here we can see that we have 3 atoms of hydrogen. From there we have carbon, O, then we have this O, and we also have 2 atoms of carbons and the other. Now whenever we have this COO in between carbons, we are dealing with an ester. Now from this ester we need to identify which one is the alcohol part, because an ester is made up of a carboxylic acid and an ester, and an alcohol. So let's identify the alcohol. So the alcohol, how do you identify an alcohol? So you can see that there is this hydrogen, this oxygen on top of carbon. There is also this oxygen in between 2 carbons. So the oxygen in between the 2 carbons, this is the alcohol party. So that's how you identify. So this is our alcohol party. Now for this one, with the oxygen above the carbon, here we have now a carboxylic acid. So we have a carboxylic acid. Now how do we name an ester? So if you are naming an ester, you begin with the alcohol party. So let's look at the number of carbons from the alcohol. So we have 2 carbons, and the prefix for 2 carbons is eth. Now the rule is you need to add YL to the prefix of an alcohol so that it becomes ethyl. If it's methyl, ethyl, propyl, butyl, depends the number of carbons. Then let's also look at the number of carbons on the acid part. We have 2, so we are also going to have eth. Now for the alcohol party, you need to add, so this becomes ethyl ethanoate. So whenever you see OAT, this means you are dealing with an ester. So this is how you can name an ester. And if you want more of these organic questions, please drop a comment in the comment section below, then I'll see what I can do. So the answer for this question 20 is C. Okay, now let's move on to section B. So section B, answer all questions in this section. So I expected to answer all the questions. Now let's look at the first question, question B1. Matter is made up of 3 basic units. Remember not to confuse basic units with states of matter. The states of matter are solid, liquid, and gas. But for the basic units of matter are atoms, ions, and molecules. So these are the 3 basic units of matter. Now B, give the basic units of matter contained in a common salt. So common salt is sodium chloride. That is its chemical name, sodium chloride. Sodium has a positive charge, so it is a metal. Chloride has a negative charge, so it is a non-metal. So whenever you have a compound with charges where you have a positive charge and a negative charge, you are dealing with an ionic compound, and an ionic compound contains ions. So these are the basic units of matter that are found in this common salt. Now for question C, noble gases like argon are made up of one of the basic units particles. State the basic unit particles in a noble gas. Noble gas are elements from group 8. Group 8 elements are naturally stable. So they exist just as atoms. They are monatomic. They consist of only one atom. So here, from the 3 basic units of matter, here we are dealing with atoms. Okay, now let's move on to question B. The table below shows the descriptions of substance A, B, and D, C. Roman number 1, give the physical state of each of them. So the first one, description, then state of matter. The first one, particles occupy any space available. Any space available. So particles occupy any space available. So this is a liquid. That's why we say a liquid does not have a fixed shape. A liquid, also a gas, behaves in this particular manner. Any space, so the amount of space, let's just go with the here. Okay, let's just use a gas since we are looking at any space. So meaning this is a set of matter with no fixed volume. So we use gas because it can occupy any space. Okay, that is the answer. Then particles closely packed, solid. Then here, particles move randomly within the space of the substance, randomly. So we have a liquid. Now question C, Roman number 3, how can substance C attain the structure of substance A? Substance C is a liquid. Then substance A is a gas. So how can we convert a liquid into a gas? A liquid into a gas by heating. Or we can just say through the process of evaporation, because evaporation is the change from the liquid into a gas state. Now for question B, substance B is said to be pure substance, pure. Give a characteristic which proves that B is a pure substance when melting. So for us to use melting to give the purity of a substance, any pure substance has a fixed melting point. So it has a fixed melting point. Okay, now let's move on to question 3. Question 3 reads, the diagram below show atoms of sodium and chlorine. Okay, so we can see that we have one electron in this particular sodium atom. So sodium is coming from group 1. So sodium is in group 1. And all group 1 elements are metals in nature. Then chlorine has 7 electrons in its outermost shell. So we have 7. All the group 7 elements are non-metals in nature. So we are looking at the reaction between a metal and a non-metal. So here we are expecting to have a transfer of electrons, or a transfer of electron from this metal to a non-metal, so that they attain the stability. Now let's look at the first question. State the type of bond that exists in the compound formed when the 2 elements combine. So if you are looking at the type, if the question is requiring you to find or to say the type of a bond, just look at the just look at the nature of the two reactants. If the reaction is between metal and a non-metal, you have ionic bonding. If the reaction is between non-metals, then you have a covalent bonding. So here we have a metal, sodium is a metal, then chlorine is a non-metal, so we have ionic bond. We are looking at a metal and a non-metal, or electrovalent bond. Then for B, draw the structure of the compound formed when the sodium and chlorine combine. So these will combine in a 1-to-1 ratio. Why? The number of electrons that should be lost by sodium is equal to the number of electrons chlorine requires. So here we can see that we have equal. So we are expecting to have only 1-on-1 ratio. Now let's look at this structure. So let's have sodium has this first shell, 2 electrons. Then the second shell here has 8. Then the outermost shell has 1. So we have 1. Then for Cl, the first shell 2, the second shell 8, then the third 7. So there will be the transfer of this 1 electron from the sodium atom to the chlorine atom. So our final answer will begin by writing the sodium. So sodium has only now 2 shells because the third shell, that electron has been lost. So it has lost 1 electron. So we put the charge of plus. Then for Cl, we are going to have the 3 shells. Now the third shell will be now fully. So we can now indicate then this X represents the 1 electron that came from the sodium atom. So this is our final answer. So the positive charge indicates the loss of electron, while the negative charge indicates the gain of electrons. So these two now are electrically stable. Then Roman number 2, state the chemical formula for sodium chloride. For us to come up with the chemical formula, we need to look at the valences. So sodium has a valence of 1. Chlorine has also a valence of 1. So if we interchange here, we are going to get sodium chloride. Okay. Now let's move on to explain in terms of bonding and structure why sodium chloride has the following properties. 1, a very high melting point. So from the diagram, we can see that we have the opposite charges. There is a positive and a negative. So here, these 2 atoms will be attracted to each other via the opposite charges. So if we want to melt, if we want to separate these 2, a lot of heat energy is required to break this electrostatic kind of bonds. So the key point here is the bond that is formed with opposite charges, or the bond that is formed between a metal and a non-metal, is very strong, and for you to break those strong bonds, a very high energy is required. That is why ionic bonds have high melting point. So we can say, so because ionic bond requires a high melting, a high heat energy, to break the electrostatic, I'll finish it here, to break the electrostatic bond. So these bonds are very strong, and the reason why they are very strong, because of the two opposite charges. So positive and the negative will attract to each other. Now for Roman number 2, high electrical conductivity when molten. So we can now see that since we have these charges, we have ions, and whenever we have ions, electricity can be transferred. So where the reason why these compounds has high electrical conductivity is because they are free ions, they are free moving ions when dissolved in, or when exist in moltens. So because they have free moving ions in molten state. That is one of the reasons that we can give behind the conductivity of ionic compounds in molten state. Okay, now let's move on. Okay, so now we can move on to question 4. So question 4 reads, both barium carbonate and barium sulfate are insoluble in water. Question A, choose a substance from the following list to fill in the blank spaces for the preparation of barium sulfate. The first substance, sulfuric acid, nitric acid, leads to sulfate, magnesium sulfate. Now let's look at the question. Barium carbonate is added in excess to a solution of dilute dash, the first stage. Then the second one, the excess barium carbonate is filtered off to collect a suitable filtrate. The second one, the filtrate is then added to a solution of dash to produce barium sulfate, which is filtered off from the product mixture. Now here, we have to be extra careful here. Barium carbonate is insoluble. So we want to use the insoluble salt to produce a soluble, then from there to produce an insoluble. That's the key pattern here. So the first, for us to produce an insoluble salt, the first thing that we are going to do is we need to react the barium with nitric acid. Because if this nitric acid react with barium carbonate, we are going to get the barium nitrate, which is a soluble salt, plus water and carbon dioxide. So here, the first one, we want to form a soluble salt from an insoluble salt. That is our first step. So we react with nitric acid. Then after this reaction, there will be some excess barium carbonate that should be filtered off to collect a suitable filtrate. So since here we have a barium nitrate, which is now soluble, it is dissolved in water, those excess barium carbonate will be insoluble. They will be in particles, so they have to be filtered off. So after we filter, we have this now barium nitrate, which is the soluble salt. This now should be reacted with sulfuric acid. So the second step here is sulfuric. Why? So that now we can produce the sulfuric. The sulfate can react with the barium to give us the barium sulfate. Maybe for the sake of the picture, okay, we'll just look at that later. B, Roman number 1, what type of reaction is used to prepare barium sulfate? So the method that is used to prepare an insoluble salt is known as precipitation. Then for Roman number 2, construct a balance equation for the reaction that produces barium sulfate. So we just focus on the second one. So the second one is barium nitrate. This barium, we have nitrate, we have a 2. Since barium has the valence of 2, nitrate has a valence of 1, so we can now see here what we are saying is barium has a valence of 2, nitrate is a radical, has a valence of 1. So if we interchange, since this 2 is affecting the 2 atoms, nitrogen and oxygen, this should be enclosed in brackets. So that is where the chemical formula is coming from, plus sulfuric acid aqueous, here also aqueous since it's soluble. So we can now obtain barium. Barium has a valence of 2, sulfate has a valence of 2. These numbers are even, so they can cancel. So we have barium sulfate here. Barium sulfate is insoluble, so we put S. All insoluble salt has a state of solid. Plus, what else are we getting? Nitric acid. So when this nitrate react with hydrogen, we get the nitric acid, which now can be filtered. So let's put what are we going to put? Let's put aqueous. So let's see if we can balance this equation. So let's look at the barium. So for barium, we have 1. Then also here we have 1. For sulfur, 1. Now let's look at let's balance nitrogen. So we can see that here we have a 2. These 2 will multiply with the N. So we have 2 atoms of nitrogen. So 2 atoms of nitrogen. Then we need to put 2 here so that we can have 2 atoms of nitrogen and 2 atoms of hydrogen. Also here 2 atoms of hydrogen from the sulfur, from the sulfuric acid. Then 6 atoms of oxygen plus this 6, 10. So even here, so our equation is now balanced. Now let's move on to question 5. Now for question 5, magnesium oxide react with dilute sulfuric acid as shown below. 600 grams of magnesium oxide was react with 980 grams of dilute sulfuric acid. The first one, determine the limiting reagent in the reaction. So the limiting reagent or reactant is any reactant that is insufficient and any reactant that is going to be used up before the other one is done. So we can't tell by looking at the numbers. We need to find the number 1, the moles for each. Now let's first check if our equation is balanced. So 1 atom of magnesium, 1 atom of magnesium, oxygen, we have 1 from magnesium oxide and 4 from sulfuric acid, so we have 5 atoms. Even here we have 5. Then 1 sulfur, 1 sulfur. Okay, our equation has been balanced for us. So our first step is we need to find the number of moles for magnesium oxide. So let's find. So I'll put Mg off just for indication. So number of moles is equal to mass over molar mass. So the mass for magnesium oxide is 600 grams over, now let's look at the molar mass. So the molar mass is equal to mg, m times 1 plus 1 times, there is one atom of magnesium and one atom of oxygen. So magnesium has a mass number of 24 times 1 plus 16 times 1. So 24 times 1 is 24 plus 16. 16 plus 24, here we get 40. So divided by 40 grams per mole. So if we divide 600 divided by 40 divided by 40, I'm getting 15. So 15 are the moles of magnesium oxide. Let's also now look at the moles for sulfuric acid. So number of moles for, we can put HSO4 just to indicate, is equal to the mass over molar mass. Let's look at the molar mass. So from the sulfuric acid, there are 2 atoms of hydrogen plus 1 atom of sulfur plus 4 atoms of oxygen. Hydrogen is 1 times 2. Sulfur has 32 times 1. Oxygen 16 multiplied by 4. 1 times 2 is 2 plus 32 times 1 is 32 plus 16 times 4. 16 times 2 is 32 plus 32, that is 64. So let's now add 64 plus 32 plus 2, getting 98. So my final answer here is 98 grams per mole, since it's molar mass. So let's proceed now. The mass for sulfuric acid is 980. So 980 grams over 98 grams per mole. So if we cancel the grams, if we divide 980 divided by 98, we are getting 10. So the number of moles for sulfuric acid are 10 moles. Now, after we are done finding the number of moles, we need to divide by the mole ratio. Now, in our case, we are lucky, since we can see that we have the mole ratio is 1:1. So since they are just 1:1, we'll just go direct and compare the two. Now, if we had numbers like 2 or 3, we would have divided by each number, its mole ratio. But in our case, we have just 1:1. So whenever we have 1:1, we just go direct and compare the two. So from the question here, we can see that magnesium has more number of moles compared to sulfuric. So therefore, sulfuric is the limiting reactant. So the limiting reactant is the one with the less number of moles. So sulfuric is the limiting. So if sulfuric is the limiting, magnesium is in excess. That's a key. Okay, now let's move on to question B. Question B, calculate the mass of magnesium sulfate that was obtained at the end of reaction. So let's first look at it. Let's write the number of moles for magnesium oxide is 15. That's what we calculated. Then the number of moles for sulfuric acid is that is 10. Now the question is, we are trying to find the mass of magnesium. So for us to find the mass of magnesium, we need to first, let's look at the formula. So mass is equal to number of moles multiplied by the molar mass. So for us to find the mass, we need to first look at the number of moles. Now we have the equation. The equation was this magnesium oxide plus sulfuric acid gave us magnesium sulfate plus water. So plus water. Now from the equation we can see that it is balanced already. Now the key point here is we look at the mole ratios. So the mole ratios, we can see that we have 1 on 1. There is 1 on each substance. Now the question is between 15 moles of magnesium oxide and 10 moles of sulfuric acid, which one are we going to use in order to find the number of moles of magnesium sulfate? Because the whole question is about magnesium sulfate. So the key point here is, if you are dealing with a limiting reactant, use the number of moles of the limiting reactant to find the number of moles of another substance. So here we cannot use the number of moles for magnesium oxide since the magnesium oxide was in excess. So there was a certain amount of magnesium oxide that remained unreacted. So that may give us the numerical values incorrect. So we use now for sulfuric. So for sulfuric here we can see that we have 10 moles of sulfuric, since this one it reacted completely. So if we have 1 as a mole ratio for sulfuric acid and 1 as a mole ratio for magnesium sulfate, how many number of moles of magnesium sulfate do you think we can get? So just look at the number, the mole ratio. Sulfuric acid has a 1, even magnesium has a 1 here. So since they have the same number of the same mole ratio, they are going to have also the same number of moles. So even magnesium sulfate has 10 moles. So we can now proceed 10 moles times now we can now find the molar mass. So the molar mass for magnesium sulfate, so we have 1 atom of magnesium, 1 atom of sulfur, plus 4 atoms of oxygen. So magnesium is 24 times 1 plus 32 times 1 plus 16 times 4. So 24 times 1 is 24 plus 32 plus 64. So let's add 24 plus 32 plus 64. I'm getting about 120 grams per mole. So we multiply by 120 grams per mole. So this mole and this will cancel. So 10 times 120 is 1200 grams. So this is the theoretical yield. Theoretical yield looks at the mass or the amount of a substance that we are expecting based on a calculation. Now the actual is now what we have gotten. So let's look at now question C. 1080 grams of magnesium sulfate was obtained at the end of the reaction. Calculate the percentage yield. So the formula for percentage, so percentage yield is equal to actual yield divided by theoretical yield. So in most cases, theoretical yield is calculated. Now actual is typically is given from the question. So the other key is the actual is always less than theoretical. So we can see that 1,200 is greater than 1,080. So this 1,080 will be on top over 1,200 multiplied by 100%. So if we do math, 1,080, so 1,080 divided by 1,200, so I'm getting 0.9 here, multiplied by 100%, this will give me 90%. So this was the percentage yield. So remember, whenever I deal with percentage yield or percentage purity, the formula is actual yield over theoretical. The actual is what you have gotten, the actual things that you have gotten. Then theoretical is what you were expecting or based on calculations. Now we move on to question 6. Question 6, the graph below shows the collection of oxygen gas during an experiment over 60 seconds from 1 molarity hydrogen peroxide. So here we have been given a concentration of this hydrogen peroxide. It's 1. Now we can now study the graph. Okay. Then in the x-axis we have time. In y-axis we have volume. Now question A1, describe how the rate of this reaction changes with time. Okay, let's start this. So at the beginning, we can see that the curve is more steeper. Then as the time proceeds, this graph started to bend in a direction making it parallel to the x-axis. So what this indicates is as the time is proceeding, the speed of a reaction started to decrease until it stopped. How do we know that the reaction stopped? Because there is this point where our curve is parallel to the x-axis, or we can say that there was a time where the volume of oxygen stopped to be produced. It remained constant. So whenever you have maybe concentration or volume in our case, whenever the reaction stops to produce a certain amount of a substance, that is an indication of the reaction to stop. Now, so we can now say as time proceeds, as time changes, the reaction, the speed, let's say the speed of a reaction started to reduce. Started to reduce. So it started to reduce until it stopped. Okay, so we have Roman number 2. At what time does the reaction come to an end? Give a reason for your answer. So let's look at this graph. Now if this graph is unclear, you may use the actual past paper so that you may get the correct answer. But the point is, for you to find where the reaction stopped, you just look at the point where the line was straight. So from the graph here, it is about somewhere here. So this is about 45 seconds. 45 seconds. So give at what time does it? Now give a reason for your answer. Because the volume of oxygen remained constant. So the volume of this oxygen gas remained constant, indicating that now there was no reaction since the product stopped to be produced. Now for question B, how much volume of the gas was produced at the time the reaction came to an end? So we need to, this is where we need to go into the y-axis, so we can see that we are reaching at 60. So 60 cubic centimeters of oxygen was produced. Now for C, sketch on the same graph a curve obtained if two more hydrogen peroxide but of the same number of moles were to be used. So here we can just see that the concentration of the given graph was 1. So if we increase from 1 to 2, so we want to double. So we can draw the curve. Our new curve can be like this, somewhere here. So this is now our new curve. How did we know? Because this one, the reaction will be fast. When the reaction is fast, the curve is almost closer to the y-axis. How did you know that the reaction is fast? Since the concentration was increased. So if you increase the concentration of the reactant, you increase the speed of a chemical reaction. So this is how we can find our answer. So the concentration was doubled, the reaction also should be doubled. Now let's move on to question 7. Use the periodic table to help you answer this question. So I have the periodic table here with me. Then question A, name the element in group 5 which is in the same period as sodium. So sodium has 11 electrons. So if we were to draw the atom for sodium, we are going to have 3 shells. So the first shell will occupy the 2 electrons, the second 8, making it 10 plus the one in the outermost shell. So since this sodium has 3 shells, therefore it is found in period 3. So the number of shells an element has determines the period in which it is found. So we are looking at now the element that is found in group 5. So group 5, which is in the same period as 3. So on my periodic table here I have phosphorus. When you look at period, we are looking at the horizontal rows. Then let's move on to this question B. Question B is state the number of protons and neutrons in one atom of the element named in above. So let's look at this phosphorus. The symbol is P. The mass number is 31. Then the atomic number is 15. So the first question is protons. So we have 15 protons since this is before the reaction. So it is just in its atomic structure. So this number here, this is an atomic number. So 15 number of protons. Protons are subatomic particles with a charge of positive. Now for neutrons, for us to calculate the neutrons, we need to subtract 15 from 31. So just say 31 minus 15. So here we can see that we have 16. Or number of neutrons can be found by subtracting the atomic number from the mass number. That's a formula. Then question C, write the electronic configuration of the element named in A. So electronic configuration EC. So we can see that we have 15 electrons in total. So the first shell will occupy 2. So 15 minus 2, we have 13. The second shell will occupy 8. So 13 minus 8, we have 5. Then the outermost shell will occupy 5. So this is the arrangement for this particular element. Now we can move on to question D. Explain why the named element is placed in group 5. So the reason why it is placed in group 5, this 5 here, the 5 indicates the number of electrons in the outermost shell. Since this phosphorus has 3 shells, the first shell 2 electrons, the second 8, the third shell 5. So the number of electrons in the outermost shell determines that. So because it contains 5 electrons in its outermost shell. Okay, now we can move on to question 8. Brass is an alloy of 2 elements. So an alloy, we are just looking at a substance that can be formed when 2 or more elements are combined. So here, not chemically, we are just looking at we combined 2 elements. So an alloy, define the term alloy. Is a substance with 2 or more metals combined, 2 or more metals combined together. Remember, sometimes it can be maybe a non-metal and a non-metal. It's not only. So let's put slash. So 2 or more metals / non-metals combined together. Then B, state the 2 elements that make up brass. So brass is made up of zinc and carbon. Then for the second one, the C, draw a general structure that represents the bonding in brass. So here, what we can just do is we use just this small circle will represent the atoms of let's say zinc. Then these big atoms will represent atoms of carbon. So that's what you do. You just make up something like this. Since we have combined the 2 elements. So this is how you can draw a general structure of an alloy. So we can these small circles will just say carbon. Then for this one here, this is our zinc, and you can see that there are more atoms of carbons compared to those atoms of zinc. And in terms of proportionality, the percentage for carbon is greater than that of zinc. Now let's look at D. Why is a bar of brass harder than a bar of the individual elements it is made of? For a bar of, let's say this individual brass harder than a bar, let's say zinc. If we, okay, let's just say carbon. Carbon has these atoms in terms of the structure we are trying to make. So if we are to apply the force here, it is easier to push these atoms, a layer of atoms on top. But for this one, since we have now some of the big atoms in between these smaller, we are going to, it is hard to push these atoms. So the answer, we can say because it is made up of different atoms that are hard to slide. On each other. Okay, now let's move on to question 9. So nylon and terylene are polymers. The first question, what is meant by the term polymer? Polymer is just a large macromolecule made from 2 or more monomers. So if you combine the 2 or more monomers, you form what we call a polymer. So a polymer is a macromolecule. Macro means big. Molecule made from 2 or more small monomers. Then the question is B, apart from being polymers, give one similarity between the two. So the similarity between nylon and terylene, these are synthetic polymers, they are man-made. They are synthetic polymers. So this is also a similarity. Or maybe we can say they are both condensation polymers. Now let's go to C1. Which of the two polymer is a polyester? So we are looking at the one with a linkage of an ester. So this one is terylene. Terylene is a polyester, while a nylon is an amide. It has an amide linkage, like those in proteins. Now, Roman number 2, hence draw the structure of the polymer showing 2 repeating units. Encircle any linkage on the chain. Okay. So the reaction between di-O, so di means 2, then O, alcohol. So di-O plus dicarboxylic acid. Dicarboxylic acid is equal to terylene plus water. Remember, the formation of nylon and terylene produces water as well. Okay, so let's make this as a structure. So the structure for dio, it's this OH, then this box another OH. So this OH indicates the alcohol. That's why we have this name of di, means to OL, alcohol, plus C. Then for dicarboxylic acid, so we have this. Okay, I've forgotten one. Now we can see that we have these two carboxylic functional. Now for us to make the structure, what you do is you need to remove the hydroxide from the diol and the hydrogen from the dicarboxylic acid in order to make this pterylene. So the key is you just write the remaining part. So the remaining is we have this hydrogen, or we can just, or then we have this box here, then connect to this O, then we have a C, or then this box here, and the C that we want, O plus C H2O. So we are told to encircle any ester link. So this is now our linkage. So from the linkage we can see that we have COO. This is what we call an ester link. So the link is just the part in between the two monomers that is linking, or that is bringing the two monomers closer. So the key point is if you are trying to form pterylene, you need to react a diol and dicarboxylic acid. Okay, let's move on to section C. So answer any two questions from this section. Write your answers in this separate answer booklet provided. So let's see what we can do. Iron is extracted from its ore in a blast furnace. So this is now an extraction of iron. So we have been given the structure for a blast furnace. Now the first one, coke and materials X and Y are fed into the furnaces. The first one, A, name X and Y. So I will just use their variable space, our X and Y. So apart from coke is the name for carbon. So apart from coke or carbon, what else is fed into this blast furnace? So we have the hematite. So hematite is now the ore for iron. Then the other one is limestone or calcium carbonate. Okay, so we are done with the first one. Let's look at the second one. What is the use of waste gases? So the waste gases that we have during the extraction of iron is carbon dioxide. So the use of carbon dioxide, it is used in fire extinguishers. So it is used in fire extinguishers. Apart from fire extinguishers, it is used during the formation of carbonated drinks. It is used by plants during the process of photosynthesis, etc. Now let's move on to see Roman number 1. What is the reducing agent in this extraction? So the extraction of iron involves carbon monoxide as a reducing agent. Okay, then describe how the reducing agent is produced. So carbon monoxide is produced between the reaction of carbon dioxide and the carbon. So would say carbon monoxide. So carbon monoxide is produced through the reaction of carbon with carbon dioxide. So if you react carbon with carbon dioxide, carbon monoxide will be produced. That's the key. Now, so this is our Roman number 2. So let's go to what is the purpose of each of the following. Hot air. So hot air to react with carbon to form carbon dioxide. To form carbon dioxide. I'll just write it. So that's the key. So it's now carbon plus oxygen, which is hot air, will give us now carbon dioxide. Then coke, we can say to react with hot air to give us carbon dioxide, or we can just say to form the reducing agent. The reducing agent. Okay, now let's look at question E. Show the balance equation in which iron is extracted from the ore. So there are about 5 equations that we have. The first one, carbon react with oxygen to give us carbon dioxide. The second one, carbon dioxide react with more carbon to give us carbon monoxide. The third one, carbon monoxide react with iron 3 oxide to give us iron plus carbon dioxide. Then the third one, we have decomposition of calcium carbonate to produce calcium oxide plus carbon dioxide. Then calcium oxide will react with silicon dioxide to form calcium silicate. Now, among these 5 equations, we are looking at the third one, which summarizes the extraction of iron. So this equation is, so we have iron. So this is the chemical formula for iron 3 oxide. React with carbon monoxide, which is a reducing agent. Then the oxygen from the iron will react with carbon to give us carbon dioxide, giving us iron plus carbon dioxide, which is now a gas. So the remaining part here, we just have to balance it. So we just need a 2 here. Then for carbon, we need, let's put a 3 here, so that we put a 3 here. Let's first get rid of this. So let's look at no, this is quite okay. So 3 iron, 2 iron, 3 atoms of oxygen from this iron oxide plus 3 atoms 6, then 3 times 2 6, 3 carbon. So our equation is balanced. So this is the third equation that summarizes the extraction of iron during in the blast furnace. Okay, now let's move to C2. So now for C2, nitrogen is used to manufacture ammonia as shown in the diagram. So the diagram, we have nitrogen plus Xe, then we have Y degree Celsius, Z ATM plus catalyst is equal to ammonia. So whenever we have nitrogen plus this unknown reactant giving us ammonia under the given conditions, we are looking at the production of ammonia using the Haber process. So the first question, question A, name the process shown above. So the reaction of hydrogen plus nitrogen to give us ammonia under the given condition is known as Haber process. Then state the substance represented by letter X. So let X, so since here we have nitrogen, the other reactant in the Haber process is hydrogen. So our X is hydrogen. Okay, now for question C, write the conditions represented by Y and Z needed for the process. So Y, we can see degrees Celsius, Y is temperature. Then Z, ATM, is pressure. Okay, so now let's move on to question D, Roman number 1. Name the catalyst used. So the catalyst used during the preparation of ammonia by Haber process is iron. So powdered iron. Then write the main ore from which the catalyst named is extracted. So iron is extracted from hematite. That is the ore. Then construct a balanced chemical equation for the reaction shown in the diagram, including state symbols. So the reaction is hydrogen diatomic, a gas, plus nitrogen, also diatomic. Then we have this equation giving us the chemical formula for ammonia is NH3, a gas. Where NH3 is coming from is the nitrogen has a valence of 3, hydrogen has a valence of 1. So if we use the cross method, we can see how this is coming. So let's balance it. So the balance is, we have 2, so we can put 2. So we have 2 atoms of nitrogen, also 2 atoms of nitrogen. But if we multiply 2 times this 3 for hydrogen, we have 6. So we need a 3 in front of hydrogen. So that is our balanced chemical equation. Then state 1 use of ammonia. It is used to make fertilizer. So to make fertilizer. Okay, so let's move on to question 3. Butene C4H8 is a compound belonging to the alkene series. Alkene, so we are dealing with those with E. State the general formula for the alkenes. So alkenes has the formula CnH2n. Okay. Now draw the displayed formula for the second member of the series. Second member. So the second member we can now calculate. Let's first find its molecular formula. So second member, where there is N, we put 2. So here it's 2 times 2. So C times 2, 2. 2 times 2, 4. So the molecular formula is C2H4. Now if you are drawing the structure, you first begin by writing the carbon. So we can see that we have 2 carbons. Now since we have the alkenes, the E, we need to put a double bond here. Then this hydrogen was here, also this one here, here, also here. So this is our displayed structure. So whenever you're trying to find the chemical formula for a given compound, use the actual formula. So use the actual formula. Now let's move on to question C. Butene is prepared by cracking petroleum ores. Name the other method by which it may be prepared. So if you want to prepare butene, we can also prepare butene by dehydration of butanol alcohol. If we remove water from butanol, we can form that. So we'll say dehydration. Dehydration of butanol. Now we can move on to question D. So but1en can be polymerized. So this one indicates the location of the double bond. So the double bond is located on the first carbon. That's what it means by the numbers. So what we are saying is the butene has 4 carbons. So these 4 carbons. So the double bond should be located between the first carbon. This is our first carbon, second, third, fourth. Or if you want, we can number it from here: 1, 2, 3, 4. So if we number it moving in this direction, then our double bond would have been placed here. So the number, whenever you see a name with a number indicates the position of a function unit or party kinase. So in our case, double bond. So now the first one, name the type of polymerization it undergoes. So this can undergo addition polymerization. Addition is where we just add. Now draw and give the name of the polymer formed from but1en. Show at least 3 repeating units. Okay, so let's look at this formula. So we can, butene has 1, 2, 3, 4. So we are told at least 3. So this is 1 butene plus another one plus another one plus another one. Now, so we need 3 of these for us to form this particular polymer. So what we are going to do is we can just write 1. So let's use the easiest way. We'll just write 1. Okay, so the easiest. So 1. So this is the structure of 1 butene. Make sure each carbon must have 4 bonds. Then I will just enclose this in brackets. Then I'll just put a 3. This 3 simply means we are using 3 of these monomers. So we can see that if we are to add all the 4 carbons, or if we multiply the 4 carbons times 3, we are expecting to get 12. So 1, 2, 3, 4, 5, 6, 8, 9, 10, 11, 12. So this is now the picture. But for you to understand this, you need to just go through the whole topic for organic chemistry. It will make sense. It is simple. So we can write it, but there are so many ways in which you can we can just compress it, but let's just write it like this. So these are the hydrogen atoms on each bond. Then there will be 2 bonds where we are not going to indicate anything. We are going to have open bonds where we would expect to bond with another monomer if we were to add another one. So we can answer it. So this is our displayed structure. Then also we are looking at the name. So the key for the naming is the monomer is poly. Sorry, the monomer is butene. Don't focus too much on the number. So the monomer is butene. So for you to name the polymer, you just begin with the word poly. So poly, then you add the name. So polybutyl-1Ne. So this is the name. Now for question E, butene react with steam in the presence of a catalyst to form a colorless compound. So whenever an organic compound reacts, such as the hydrocarbons react with steam, they form alcohol. So name the compound formed. So since we are using butene, the alcohol is butanol. So if it's ethene, ethane, propene, propane. So the name of the hydrocarbon used would determine the name of the product that you are going to get. Now let's do what are we going to do? Okay, let's now write the final answer. Write a balanced chemical equation for the reaction between ethanoic acid and the compound formed here. So it's a reaction between an acid and an acid and an alcohol. So here we are looking at esterification. So for the sake of space, I will just write it on top here. So the chemical formula for butanol, we have how many? 4 carbons. So butanol, CH. So since we had 8 plus 1 from water, we can now put we have 9 OH plus C, reacting with ethanoic acid. So ethanoic acid has CH3. Okay. So we need to get rid of what will form water. So what we are going to do is from the alcohol we'll remove hydroxide so that we have C4H9. Then from this acid we'll remove hydrogen so that the hydroxide plus the hydrogen will give us water, since the esterification produces water also. So if we remove this hydrogen here, we can see that we have COO CH3 plus CH2O. Now the good part for these equations, they are balanced equations. Then the first one, alcohol, this is a liquid. Acid, we have aqueous. Esterification, aqueous. Then liquid. So this is how we can answer. Some of the ways we can answer, because some of these questions may have different ways, or maybe you can answer them in a different way. So I'm sure that's it for this video. So for those that may want to, maybe you have some topics that you think I can be of help, please feel free to inbox. That's it for this video. Thanks for watching.